complexity gate is a max for live stereo audio effect device that computes the complexity of its input signal and uses this measurement to automatically persist feedback sweet spots. It can also chaotically modulate amplitude across extreme ranges, and it can map onto other parameters in live, like this, where it's now connected to a pitch shifter. So in this video, I'm going to be walking through the controls and demonstrating how it works. Let's do it. So to contrast with what would happen if I didn't have something in the device, if I bypass this and turn this back on, it'll feed back quickly. It'll get into the red. I'm not going to do that for headphone users so they don't hurt their ears. But that's the reason that I built this device, was to build something that could automatically do machine listening techniques to persist a certain range that would go down and basically decrease gain when feedback is going up and increase gain when feedback is going down. And read some papers and kind of landed on this approach. So let's go check out maybe the simplest possible example I could show to illustrate these first couple of sections. So this section in the device is pretty self-explanatory. You can either select default, which just uses the audio input from whatever track the device is on, or you can select sidechain mode and then select a track anywhere else in live. And this scope just visualizes the input signal. Then the analysis section is where the actual complexity computation occurs. And so for that to demonstrate, I'm going to play this track 1, which starts out as white noise and then fades into a sine wave. You'll see what happens in this visualization window here. So you can see that over the course of the file, it starts out high when it's a noise input and it goes low when it's a sine wave. And that's because the analysis is essentially looking for copies in recent history that match exactly what just happened. And this is based on a statistical measurement called autocorrelation, where you look for delayed copies, you look for matches of a pattern with delayed copies. And that means that this can detect feedback, because feedback is made of tones that start to be produced by the connection between output and input, and they produce a repeating tone which can be detected. Whereas with noise, there's no repetition in noise, so the measurement is always high. Then in the rest of the analysis section, you can scale the control signal that's derived here, so you can either multiply it by anywhere from 16 to 0 to really change the kind of the gain on the control signal, and you can also scale it to be within a certain range. So just to demonstrate that quickly. Yeah, that's the analysis section. Then the next section is the gate section. And this takes the control signal that's derived in this first analysis section, and then it provides the option to only let the signal through when it passes above or below this threshold. And you can leave it at the lowest setting, which is the default, and leave it on greater than. That means that the control signal will always pass if it's greater than the lowest amount. The same would be true if you left it if it's lower than the highest amount. But in the middle, there are basically ways to gate the control signal, and you'll see what I mean when I play this file again. So once it goes below this level, it's gated. And you can see that this threshold slider matches with the visualization in the left and the right. So both of these scopes are really helpful when figuring out a good threshold value for whatever you're trying to do. Then after you've configured whatever gate, then you can slew the signal upward movement or downward movement. And this is depending on the scenario. You might want to have it reacting really rapidly, or you might want it to more slowly morph into wherever it needs to go so that can range from 0 milliseconds to 5 seconds. And that is the first 3 sections where you are creating and processing this control signal. And then in the output section, you're mapping that control signal onto a certain gain range. So there is a minimum gain range and a maximum. And whatever the lowest complexity measurement is mapped onto the minimum. Whatever the highest complexity measurement is mapped onto the maximum. And this allows you to take the complexity measurement and then apply a sort of gain envelope to your input signal that it corresponds to how complex it is. So of course, like min can go above max and you can invert it if you want. The default is for the maximum to have 0 gain applied and then for the minimum to have negative 36 decibels applied. And I've just found that somewhere around there is pretty good for actually just, getting started with a feedback loop, but it's very much dependent on your speaker, your microphone, and stuff like that. After that, you have output gain, which can go from plus 32 down to negative 70. There's a built-in limiter, which is set to on by default, but if you're working with like 32-bit float, it might be useful to turn it off in certain situations so you can disengage it. Then there's an LPF, which is useful for getting rid of really, really harsh high-frequency tones in certain situations. And then you can mix dry signal with wet signal. That's pretty much the digital signal processing inside the device. Then in this mapping section, you can take copies. There's 3 copies of the left complexity measurement and 3 copies of the right complexity measurement, which can be mapped onto any other parameters in live. And that's what I was doing down here in the demo originally. I dragged a pitch shifter in and then I mapped the device by clicking the button onto the parameter, and then you have sort of an audio controlled parameter that can get really, really wacky pretty quickly, especially if you have, say for example, a complexity gate controlling another complexity gate on a different track. You can quickly get some really chaotic but interesting zones going on. Okay, so that's a walkthrough of the device. I'm going to show a couple other sounds, just demo sounds. So here is a BBC sound effect. Emptying metal bucket of water into sink. I'll play it dry first. Okay. Now I will play it with the device on. Okay, and then if we sidechain a breakbeat to the track, instead of using its own audio for the complexity measurement, we'll use the audio from another track. Then here's an example where I used the complexity gate threshold on 2 different copies of the same signal. So this one has a gate that is less than this threshold, and this other one has a gate that is greater than this threshold, which allows me to sort of split the signal into 2 different tracks, where one contains the greater than, the other contains the less than. And then I can apply different effects to both of those. This is just a loop from Hey 19 by Steely Dan. Thank you for watching. This device is available on Gumroad, and that's it. Bye.